So CGP papers, foundation, practice set 2, paper 2. £10,000 place is here, so we're rounding to this, and let me write it down. 4, 7, 3, 2, 8, 7. These are the ones, tens, hundreds, thousands, and 10,000s. So we look at 3, round up or down, which can leave it as it is, 1, 7, and then we need to pad it out with zeros. We need to fill in those zeros. Those zeros are really important. -7 is greater or less than -3. It is less than. This one here, I'm going to write them out. And then I can put a 0 here, just like it would with money. This would make it 3 pence. This would make it. This is better, easier, if you can see it. 0.03, this is the same, 0.1, 0.10, and then we can see that this is the equivalent of an effect if we put a pound sign in front of this. This is 10 pence, this is 3 pence, so 10 pence is greater than 3 pence. 0.1 is greater than 0.03. 57% and 3/7. Remember, you have a calculator. You have a calculator, so 3 divided by 7. 3 divided by 7 equals 0.428. So let me write that down. 0.42857. And then we look at this, 57% would be 0.57, 0.57 and 0.428. Which one is great? In fact, we could either round it up or we could just leave this off for now. It's called truncating. Which number is greater? Well, 57 pence is greater than 42 pence. So 57% is greater than 3/7. Make sure you use what's written in the question. Use each of these digits exactly once. What's the smallest number you can make? So what I'm going to do is order these numbers in numerical order, ascending numerical order, starting with the smallest number. And then the next number is 3, and then 5, 6, 7, and 8. If I was to swap these two numbers round, for instance, if 8 and 7 here, it would be 87 at the end rather than 78, and therefore the number would be biggest, so I have the smallest number. What's the largest even number? Now this is really key. If we just ordered them largest to smallest, then we would end up, the smallest number is 1, and we don't want that number at all. So what we do is we look at the largest number that we can make. We're looking at 8, then 7. Now we're looking at an even number, so it has to end in the smallest even number that we've got. So we're going to put 6 at the end here, and then we're going to carry on with the 5, 3 and 1. This is the largest even number that you can make. Divide by 2 again. Three litres. 3 litres, 1 litre equals 1,000 millilitres. Milli means 1,000, just like kilo means 1,000. Millilitres. 1 litre is 1,000 millilitres. So we could write this as 3,000 millilitres to 250 millilitres. So this is 3 litres. We've swapped it here, and then we just simplify this. Now I can see that there's a 0 and a 0, so I'm going to divide to start with by 10. Now I can see actually that 25s go directly into 300, so I could divide by 25. I could divide by 5 if you preferred. I'm going to go straight for the 25. So there's 125 here. How many 25s? Well, if we went 25, 50, 75, 100, there are 4 in 100. We've got 300 here, which we could have 3 columns of the same. So then, therefore, we've got 3 lots of 4, which is 12. So we're looking at 12 to 1. Make sure you put that on the line. Question 5. So we complete the table. We've only got red, blue or yellow, so therefore we know that if we add red and blue and yellow together, it needs to equal 1. So what we do is we find what red plus yellow is. This is the red, this is the yellow. We've got a calculator, use it, 0.55. And then what we do is we take that away from 1. So 1 subtract 0.55. As I say, you've got a calculator, use it. 1 subtract 0.55 and we get 0.45. £40 in the pencil case altogether. In total, how many are either yellow or red? So what we're going to do is we've already added together the yellow or the red, so we know the probability of getting a yellow or a red. The probability of getting yellow or red equals 0.55. So we take the 40 and we multiply it by 0.55. And we get 22. Question 6. Now these questions look horrible, as in that they aren't questions that we're used to, but they're about money, and you know about money. The key to these questions are it talks about different coins. So we're looking at different coins here, they're not the same coins. Then work through the question, working out what each of the elements means. His total in pence is a factor of 99. So let's talk about, right, what are our factors of 99? 1 and 99. 2 doesn't go, it's not an even number. 3 and 33. 3 multiplied by 33 is 99. We've also got 9 and we've got 11. So these are all the factors of 99. It has to be a number that's greater than 4. So total amount is greater than 4. So it's not 1, so we can cross that one off. It's not 3. It has to be greater than 4. So we're looking at these. He has 2 different coins. We're looking at 2 different coins. Can we make 2 different coins add up to 9? Well, we know we've got a 1 pence, a 2 pence. We've got a 1 pence. We've got a 2 pence. We've got a 5 pence. We've got a 10 pence. We've got a 20 pence, a 50 pence, a £1 and a £2. That's all the coins that we have. Can we add 2 of these together to make 9? 2 and 1 makes 3, 2 and 5 makes 7, 5 and 1 makes 6, so we're not going to get 9, so 9 can't be the answer. Let's have a look at 11. Well, I've got 2 different coins here. I've got a 1 and I've got a 10 pence. So 1 pence and 10 pence make 11. Gives us a factor of 99, which is 11, and it's greater than 4, yes. So I have my numbers. Katie has 4 different coins. Let's just leave those on there. Katie has 4 different coins. Her total in pence is a multiple of 20. So what we're talking about in multiples, it's going to be 20 or 40 or 60, but it has to be greater than 300. So there's no point just carry on counting here. 20 is 100 a multiple of 20? Let's have a look. Let's just carry on counting here for a minute. 80, 100. Yes. So 100 is a multiple of 20. So anything that's a multiple of 100 is also a multiple of 20. So we can say that 300 is a multiple of 20. But it has to be greater than 300. So we're going to look and count some multiples that are greater than 300. 320, 340, 360, 380. So let's look at those to start with. Let's see where we get in terms of adding 3. Now it's not 300, it's not any of these. 320. Can we make 320 using 4 different coins? Remember, they have to be different. Now, there's no point adding just my 1, 2, 3, 1, 2, 5, 10 together, because what we've got 15, 16, 17, 18 pence. We've got to get up to £3.20 or £3.40 or £3.60. That's what we're looking at. So we're going to need to get to use these two. So the first 2 coins definitely have to be £2 and £1. To get to 300, we just have to have those coins. We cannot. Oh, I've put 55 here, and it should be 50. This is 50 pence here. We've got £3. So we now need to see if we can make 20 pence with 2 different coins. Now we have a 20 pence piece, but we need 4 coins altogether. So this isn't going to work. 10 pence, and we can't add 2 of these coins together to make 20. So this one's not going to work either. What about 40? Now we've got 20 pence, so we could use a 20 pence here. 20 plus 10 would only get us to 30, and we can't add another one. 50 is too much, so we can't add this one either. So it's not £3.40. Let's have a look at 360. How can we make 60 pence with 2 of these coins here? Well, we've got a 50 pence and we've got a 10 pence. So the 3 coins, and this equals £3.60. So we've got a £2 coin, a £1 coin, a 50 pence, and a 10 pence coin. Tim has 3 different coins. Prime number. Okay, so we need to use the information about prime numbers. What do we know? It needs to be less than 15. So I'm going to write out every number between 1 and 14. It has to be less than 15. 1, 2, 3. Okay, so these are all my numbers. I know, use the algorithm to be able to work out which ones are prime numbers and which ones aren't. We know that 1 is not a prime number. It only has 1 factor. A prime number has to have exactly 2 factors. 2 is a prime number, and any multiple of 2 is not a prime number, so we can cross all of the even numbers off. 3, we put a ring around the next number. 3 is a prime number, and then we're looking at multiples of 3. 6, 9, 12. They've all been crossed off already. And then we've got 5. Any multiples of 5? No. 7. Any multiples of 7? No. And 11. So these are our 5 prime numbers. These are the only 5 numbers that we're looking at, and we've got 3 different coins that we have to add together to make either a 2, 3, 5, 7 or 11. Can we add 3 different coins together to make 2? Well, we've only got a 1 and a 2. No, we can't make this one work. What about a 3? 1 pence and 2 pence would make 3, but we need 3 different coins, so this one wouldn't work. What about 5 pence? If we had a 1 pence plus a 2 pence, again, we're still not getting there in terms of the 5, because we can't add another 2 pence to that, so it can't be the 5. What about the 7? 1 pence plus 2 pence plus 5 pence is 5, 6, 7, 8. No, we've gone over the 7, so it can't be this one. So we've got another coin coming on here. We've got 11, 1 pence, 2 pence, 5 pence. And we've got a 10 pence. Where does that take us? 10, 15, 16, 17, 18 takes us too far. Okay, so we've now got, and obviously we've now got 4 coins. So if we took out this coin, 10, 11, 12, 13. Okay, I've got a 13. I've got an amount that works with this one here. Let's go put it in. 1 pence, 2 pence, and 10 pence. That got to my 13 pence. Question 7. Now the question is fill in all the missing information, so we'll start with this one here. We've got 8 and we've got a tally of 8, that's excellent. So we've got 16, so we need to tally of 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We don't know about rugby yet, we're going to look at the table below. So we know that football is 8. So football is 8 and there are 2 balls here. So we divide that 8 by 2, which means that one ball here represents 4 children. This is 4 children here, this is 4 children here, this is 8 children. So if we do the same here, if this is 4 and 4 and 4, that gets us to 12. So we can actually write this as 12 here. 16, how many would this be in these balls here? How many balls would we need for 16 children? Well, we'd need 4 multiplied by 4 to get us to 16. So we need 4 balls. 1, 2, 3, 4. We put in little diagrams there. And up here we have 12, so we write a tally for 12. 1, 2, 3, 4, 5. And there we are. That would get you the 3 marks. Question 8. I'm going to write it out in big. 2x plus 3 equals 8. Now we're using reverse BIDMAS. When we solve and when we rearrange an equation, we start at level 1 here. That's addition and subtraction. So we look at where the addition and subtraction is. The addition and subtraction is just here. So what we're going to do is we are going to subtract 3 from both sides. This is addition and subtraction. We need the inverse. So then we're left with 2x here and 5 here. 8 subtract 3 is 5. We're then going up to level 2. Divide and multiply. Here, this is an invisible multiplication in here, so we have to divide by 2, which gives us x here. 5 divided by 2, which is also known as 2.5. So you could either put 5 divided by 2 here, or you could put 2.5. You've got a calculator, so you can put that into your calculator if you wanted to. Either would be correct answer. Okay, she's saving up to buy a dress. She's already saved this. She's going to add to the same as every Monday. What date will she have saved enough to buy the dress? Okay, so we need to set this out logically. She wants to buy a dress which is £36.50. She has already saved £13.10. So we need to know how much more that she needs to save. So if we put this into a calculator, 36.50, we get £23.40. £23.40. This is how much she still needs. She's going to add £4.80 to her savings every Monday, and she starts by doing £4.80 on Monday the 17th of May. So if we take £23.40 and we add £4.80, so we take this and we add £4.80, we get £28.20. And if we take £28.20 and we add £4.80, we get 33. Now where are we aiming for? Doing this right? Nah, doing it wrong. Let's start again. This is the amount that she still needs, and what we're doing is we're actually taking this amount away. So I'm just going to draw a line through this. I was concerned there because the number was going up. So we're going to start that again. £23.40, take away, subtract, which gets us to a lesser amount, which is better, £8.60, £18.60. So we're going to start with £18.60 and we're going to subtract £4.80 from that. Gives us £13.80. £13.80, subtract another £4.80. £9. £9 subtract 480. Okay, so if this is the first week, she starts by adding £4.80 on Monday the 17th of May. So this is the 17th of May here. On every Monday. So we're 17th of May, and then we have to go 1 week, 2 weeks, 3 weeks, 4 weeks. So we're looking at 4 weeks. So we're taking the 17th of May and we're adding on 4 lots of weeks. There are 7 days in a week, so we've got 4 multiplied by 7. 4 multiplied by 7 equals 28. 28 days. And we have to take Monday the 17th May, and we need to add on 28 days. 30 days has September, April, June and November. So there are 31 days in May. 31 subtract 17 means we've got 14 days left in May until we get to the 1st of June. 28 subtract 14 means we've got the 1st of June plus 14. 28 subtract 14 is 14. And in fact that's 31st of May. And therefore 31st of May plus 14 days is the 14th June. 14th of June. So what did I do there? Lots of different steps in that. Worked out how much she needed. So this was step 1. How much does she need to save? Work out how many weeks she needed to take £4.80 off in order to, that she had paid off all of, she had saved enough in order to be able to get to that £23.40. So this was step 2. And then what I then had to do is work out, going from the 17th of May, how many days did I need? Well, I needed 28 days to get to this. And going from the 17th of May plus 28 days, well, it's not just 17 plus 28, because there are more than 31 days. That would make it more than 130 days in May, and therefore I had to work out how many days were left in May and then add on the number of days to get to June. That last bit, you needed to know how many days there were in May. Important information for everyday life, really. Question 10. Patchwork quilt, sewing 900 squares. 5/18 of the squares had a pink black background. So what we're saying is 5/18 of 900, which is the same as saying 5/18 multiplied by 900, and you can just put that into your calculator. Use the fraction button. 5/18 multiplied by 900. $129 of the squares had a flower on them. What percentage of the squares have a flower on them? So we know that there are 129 out of a total of 900. Put that into your calculator. I'm going to do divide this time. You can use the fraction button. And then I've got an amount, 14.143333, and it says correct 1 decimal place. So, here is a decimal. We need it as a percentage. I was going to try and round this up here, and it would only give me a very inaccurate value. So I double checked the question, and actually it's about percentage. This is the decimal. this makes a percentage of, you multiply by 100 to get to percentage, so 14.33333%. We're then rounding to one decimal place here, which gives us 14.3. 2/5 of the squares have spots on them. Of the squares which have spots, 3/8 of them have a yellow background. Okay, so we're going to do this in stages. 2/5 of the squares have spots on them. So we're talking about total squares. There are 900 total squares. So we're looking at 2/5 of 900 to start with. So we put that in. 2/5 of 900 gives us 360. So that's the ones that have spots. Of the squares which have spots, so that's 360, 3/8 of them have yellow backgrounds. So we're looking at 3/8 multiplied by 360. This is 3/8 of 360, and again we can put this into here. So 3/8 multiplied by 360 gives us 135. What fraction of the squares are spotty with a yellow background? Well, we know that there are 135 squares, but we're looking at a fraction. So we're looking, and it says in its simplest form, 135 divided by 900 squares. We know the total number is 135. We know of that have spotty with a yellow background. We know the total number of squares altogether is 900. Therefore, we've got this as a fraction. Now, one thing you can do, it's a calculator paper, so you can put this into your calculator. 135 divided by 900 in a fraction, on a fraction button, and that gives me 3/20. So automatically, it's resolved it for me. If you do have it as 0.15, you can click the SD button, and that will give you it as 3/20. Question 11. X and Y are directly proportional. Directly proportional means that when you have X, X will be the same as Y with a constant. Don't need to worry about that for now, but what it means is when X goes up, Y goes up. When X goes up, Y goes up. That's what being directly proportional means. And this is the only graph when X gets bigger, so this is 1, 2, 3, 4, 5, 6, Y also gets bigger, 1, 2, 3, 4, 5, 6, so it's the graph C. Inversely proportional means that you've got X equals a constant divided by Y. This means that when X goes up, Y actually goes down. And the graph is one that you really just have to remember and learn. This is inversely proportional. Right, when we've got a calculator paper and we've got standard form, we put the number into our calculator. So 2.6 multiplied by, we've got this button down here. This is the standard form button, which then allows us to put -2 in here. And then we are multiplying by 3.4. Ooh. We're multiplying. I'm going to put this in brackets because I never know what my calculator is going to do, and that is a number in its own right. So I've just put brackets in here. I'm then going to open brackets here and put this one in. 3.4 multiplied by 10 to the 4. Oh, spot the mistake. I've just realised I've put a multiplication symbol in there. Right. 884. So as an ordinary number, 884 is my ordinary number. In standard form, now your calculator won't help you in this bit here. We need to find out what this is in standard form. We've got 884. Now we know with standard form we have to have a number between 1 and 10 to start with. So we know a number is going to be 8.84. And what do we do to get from 884 to 8.84? We move the place value 1, 2 to the left. We've moved it to the left, so what we have to now do is put 10 to the 2. 2 jumps plus a 2 there. This is 884 in standard form. Question 13. Maria has a coin, she tosses it 8 times and records a result in this table. What's the relative frequency of getting heads? Relative frequency. So what we're doing, we've got heads is there are 2 chances of getting heads out of a total of number. 2 hands, she tosses it 8 times, so the total is 8. 2 plus 6 is 8, which is also in the question here. She tosses it 8 times. So the relative frequency is 2 divided by 8. 2 divided by 8 gives us a quarter, also known as 0.25. Relative frequency is 0.25, also known as a quarter. Either of those would have given you marks. Maria claims that her coin must be biased. Explain why she thinks that is. Well, she got heads and tails were not, normally with a unbiased coin, you would expect there to be an equal number of heads and tails. So the fact she got more tails, that means that there's a good chance that it is. So on a fair coin, do you think Maria's had enough evidence to be confident the coin is biased? I'd say no. Question 14. Let the width of the rectangle be W. So we're going to draw a rectangle. If we said the width is W, then the length is 2.5 times by W. What's the width of the rectangle? Well, we know that the perimeter is 52.8. So if we say that 52.5 equals, now what's the perimeter? Well, we know that this length, it's a rectangle, so this length here will be W as well. This length here will be 2.5 W. Perimeter is this length plus this length plus this length plus this length. So I've got 2 lots of W and they are added together. And then I can write 2.5 multiplied by W as 2.5 W. So I'm going to write 2.5 W, add 2.5 W. I've got 2.5 plus 2.5 is 5 W. So this is 1 W and 2 W's. So this is 2 W's. There's an invisible 1 in front of each of these. Plus 5 W, which in total gives me 7 W. 5 plus 2 is 7. This is the length of the perimeter here. And therefore, if we divide both sides by 7, we have 52.5 divided by 7 gives us 15.2, also known as 7.5. 7.5 equals W. So we know that the width is 7.5. Width that's what we wanted to work out, 7.5 centimetres. 15. Dido's going on holiday to Florida and changes 450 into US dollars. Current conversion rate is 1. Actually, I'm going to pause just here. I've got a number of questions and I'm going to split this into half. So next section coming up after this.